there is a pulse, which is a disturbance pulse, disturbance given by y for various values of x. There is a pulse traveling along the x-axis, and the disturbance for various values of x at time t equal to 1 is given by this equation. That's a disturbance pulse at time t equal to 1 second. You get y for all values of x at an instant of time t equal to 1 second from this equation. Right? At t equal to 3 seconds, the disturbance pulse produced in the region is given by this x square minus 3x plus 3. We want to be able to find the wave velocity. We want to be able to find the wave velocity, right? Hey, if you recall, wave velocity is going to be, if I can write y as a function of x minus vt, then this v will give me the wave velocity or velocity of the pulse. When I say velocity of wave, means velocity of pulse, same thing. Okay. Let's start to simplify. Let's say, so at t equal to 1 second, y would be 1 by 4 into x minus half whole square, right? This is x minus half whole square plus 3 by 4. Right now? That is 1 by 4. Okay, I can leave it like this only, right? This is at t equal to 1 second, right? At t equal to 3 seconds, this y would be 1 by 4 x minus 2 into 3 by 4, 3 by 2 whole squared plus 3 minus 9 by 4. I hope you realize what I did. Express this as a perfect square, sum or difference of two squares, right? So which is like 1 by 4 into x minus 3 by 2 whole squared, 12 minus 3 by 4, right? Yes or no? We are done. This is at t equal to 1 second, this is at t equal to 3 seconds. This is at y at t equal to 1 second, this is y at t equal to 3 seconds. What I do is I generalize this. Y at x and t, then I write as 1 by 4 into x minus t by 2 whole squared plus 3 by 4. Because then at t equal to 1, I'll get this. At t equal to 3, I'll get this as my disturbance pulse. Yes or no? Right? And out of comparison, f of x minus vt, this is the function of x minus half into t. Yes or no? So this half must be the wave velocity. This half must be the wave velocity, right? So velocity of the pulse or the wave velocity is half meter per second. Yes or no? Got me? So there is a sinusoidal disturbance produced in a region, and P and Q, this is, let's say this is the direction in which the wave is propagating. It's given that the frequency of the wave is 500 hertz, velocity is 360 meters per second, and these are 2 points P and Q separated by a distance delta x, and it's given that the phase difference is 60 degrees, means pi by 3. I want to find the separation between P and Q. I want to be able to find the separation between P and Q. Hey, phase difference is what? 2 pi by lambda into delta x is the phase difference between 2 points. Lambda is the phase difference, 2 pi is the phase difference for a separation lambda. So for the same wave train, for a separation delta x, this will be the phase difference, right? I want to find delta x. Delta phi is pi by 3. Now what is lambda? Lambda is v by n, right? So 36 by 50, right? So this is 2 pi by lambda, which is 36 by 50 into delta x. So you can solve for delta x, the separation between them. You can solve for delta x, the separation between them. Yes or no? right? There is a stationary medium and there is a disturbance propagating in that medium given by a sine omega t minus kx. Alright, so this obviously is a disturbance traveling along the positive direction of the x-axis, right? Now there is a frame S which is moving with a velocity v along the negative x direction, I want to describe the equation, wave equation, in a frame of reference attached to S, in a frame of reference attached to X. You know what I'm saying? This is what I want to do. I want to write the wave equation in a frame of reference attached to S, which is moving with a velocity v along the negative x-axis, right? This is what I want to be able to do. Now, do you realize that if in a given time, with respect to the stationary frame, with respect to the stationary medium, if the disturbance propagates by an amount x, if the disturbance propagates by an amount x with respect to the stationary medium, then with respect to the frame S, see, the frame S would have traversed a distance in the same time which is vt. The frame S would have traversed in the same time a distance vt away, right? So in a frame of reference attached to S, the amount by which the disturbance would have traversed is not x but is x plus vt. Yes or no? I'll repeat now. I'm saying if in a given time the disturbance with respect to the stationary medium has moved x units to the right, but the frame itself would have moved vt units to the left. So with respect to this frame, by what amount has the disturbance moved? Vt plus x, right? With respect to the frame, the disturbance has traversed x prime, which is x plus vt, right? X prime is the distance traversed with respect to S, right? So now can I write x as x prime minus vt? Can I do that? Can I do that? Or say, what would this equation translate to? This equation with respect to the frame S would translate to a sine omega t minus k x. X is x prime minus vt, right? Where x prime is the disturbance with respect to the frame S. So which is like a sine omega plus kv into t minus kx prime, right? That's a description with respect to the frame S. That's a description of wave motion with respect to the frame S, because x prime is the amount by which the wave would have traversed with respect to the frame S. Now, hey, look, what's the actual wave velocity in the frame of reference in the stationary medium? Omega by k, right? Wave velocity in the stationary medium is omega by k, right? But what would this frame observe? Omega by k plus v. See, the wave velocity is omega by k in the stationary medium, but this frame is moving at a velocity v to the left. So this frame will observe omega by k plus v as the wave velocity. So in the frame of reference attached to S, It's omega by k plus v. Omega by k plus v is the wave velocity v prime in the frame of reference attached to S. Got me? Hey, I could have also looked upon that as, this is my new omega, this is my k. So the wave velocity in this frame is like omega plus kv divided by k, which is like v plus omega by k, v plus omega by k. Yes or no? Either way you want to look at it. Two waves traveling in the same medium must have the same velocity. Two waves traveling in the same medium must have the same velocity. No. They could be waves of different kinds. Say in a solid medium, for example, I could have had a transverse wave traveling through that medium. I could have had a longitudinal wave traveling through that medium, right? So they need not have the same velocity in the same medium, right? Also, if I get a little more finicky, these could be identical kinds of waves but traveling in opposite direction. They have the same speed but they have different velocities. Right? So they could have had different velocities even if they were theoretically the same kind of waves. So A is wrong. Two waves traveling in different medium must have different velocities. Two waves traveling in different medium, not must have, they could have. So B is wrong. They could have had the same velocity. C. Two waves traveling in different media may have same velocity. Now that's liberal thinking. That's true, that's possible. And then D, of course, is crap. So C is the only right option, right?